Hello, good morning students. So in my previous video I have discussed about the solubility and the law of flotation and sinking. So regarding that topic, no activities I have shown, just explained. Though this solubility or this sinking and floating, the rules, Archimedes Principle, though these things are not in your syllabus, but little bit extended part I have explained. So to get to know about these things for which will be helpful for your next class or your higher classes, so today I am going to give two videos regarding this activity, Archimedes Principle and the flotation and sinking of the objects or substances. So though already you have done in your previous class 5 that how an egg can float or an egg can sink in water. So if the density of the water will increase after adding salt, then it will start to float. So it is totally depend on the density of the liquid in which the objects try to float. That's why you can see the boats or the ships easily it can float in sea, because in the sea the water is present, means actually the water is there in which salt is present. So whenever you will add salt with water, its density becomes more. So if the density will become more, that means its buoyant force will also become more. As much as the density of the liquid, its buoyant force also becomes more. So whenever the buoyant force becomes more, then it will help to float the objects or the substances in it. So that's why it is very much easier to float in sea rather than in river, because in river water there is no salt is mixed up. So regarding these things you will get few activity videos, so which will be helpful to understand from those videos. So hopefully you will enjoy the next session. So wait for my next class. Thank you. Visit again.
A few days back, I went swimming with my daughter. My daughter's 4 years old and she's learning to swim. So you can imagine how the swimming session went, right? Most of the time I'm holding her up in the pool and she's enjoying herself. So while holding her in water, I realized that she feels much lighter in water than when I lift her up at home. So how can you explain that? That's right, it's Archimedes' principle. And this same principle explains why a small steel coin sinks in water, but a massive steel ship can float. But before we do Archimedes' principle, you need to understand Archimedes' volume discovery. I have a video on Archimedes' volume discovery, so if you've not watched that already, do check it out. I'll be putting a link in the description below. Now, if you look up Archimedes' principle in the textbooks, Archimedes said, "When a body is immersed fully or partially in a fluid, it experiences an upward force that is equal to the weight of the fluid displaced by it." The first time you read this, it sounds like a cryptic message from Archimedes. But don't worry. In this video, I'm going to break it down and really simplify it for you. Also, towards the end of the video, I'll be sharing a great mnemonic to help remember this principle. So do stay tuned. And then we'll finish off with our top 3 questions on this topic. Let's start with Archimedes' principle. So here's the statement. Since the statement is pretty long, let's go ahead and cut it down. So I'm going to cut out the word partially and we'll consider the body being completely immersed only. Now, what are fluids? As the name suggests, fluids are things that can flow. Liquids and gases are collectively known as fluids. So let's take the simple example of water. So I'm going to replace the word fluid with the word water in this statement. So now the statement becomes, When a body is immersed fully in water, it experiences an upward force that is equal to the weight of the water displaced by it. Now let's cut this statement into two parts. The first part is, when a body is immersed fully in water, it experiences an upward force. And the second part is, the upward force is equal to the weight of the water displaced by it. Let's understand the first part with a simple experiment. So when a body is immersed fully in water, it experiences an upward force. And that's very easy to see, because if I leave this ball, you can see it bobs up. Why? Because water is pushing it with an upward force. And this upward force is also known as upthrust or buoyant force. And you can try it out yourselves at home. All you need is a bucket of water and a plastic ball like this. So when you hold the ball down like this, you can actually feel the upward force on your fingers. So I'm feeling the force here, and again when I leave the ball, the force brings the ball up. So how do we measure the amount of upward force? We know that an object feels lighter when it's held in water as compared to air. Now why is that? That's right, it's because of the upward force of water. So the difference of the weight in air and the weight when held in water will give us the amount of upward force. Let's go ahead and try it out. For this experiment, I've taken this hollow ball and I've filled it with coins here to make it heavy. Let's measure the weight of this ball, which is filled with coins, with the help of this spring balance. So let's see what is the weight here. So as you can see here, the weight is 500 grams. Or to be more precise in physics, the weight is 500 gram force. But for this video, we'll just keep things simple and use gram as the unit of weight. And this weight is known as the real weight of the ball because it is the weight in air. Now I'm going to immerse this ball into this beaker of water, and you carefully observe what is the reading of the spring balance. So I'm going to lower the ball here. So what did you observe? As you can see, the spring balance shows that the weight of the ball when it's immersed in water is now 300 grams. So there is a loss in weight when the ball is held in water. So why is that? It's because of the upward force of the water. And the weight in water is called as the apparent weight because the ball seems to lose weight. And how much is this apparent loss in weight? It's the real weight minus the apparent weight. So it's going to be 500 grams minus 300 grams. That's 200 grams. So the loss in weight is 200 grams. And we know that the upward force is contributing to this loss in weight. So the upward force is actually the loss in weight, which is 200 grams. Or to be more precise, 200 gram force. Now let's take a look at the second part, that the upward force is equal to the weight of the water displaced by it. So I'm going to go ahead and tilt this larger beaker so that the displaced water goes into the smaller beaker. So let's try it one more time. Let's measure the weight of this water that has been displaced by this ball. So I'm going to pour this displaced water into the pan here with a weighing scale. So what is the weight of the water? As you can see, it's 200 grams. So the upward force and the weight of the liquid displaced are both 200 grams or 200 gram force. So they are equal and Archimedes is correct. Now let's go back to our statement. When a body is immersed fully in water, it experiences an upward force that is equal to the weight of the water displaced by it. Archimedes' principle also works for the partially immersed case. So for the case like this, where I have this ball partially immersed in water, so the upward force, which is measured by the loss in weight here, is equal to the weight of this water displaced. So Archimedes' principle works for both the cases, whether the object is completely immersed in water or partially immersed in water. And in fact, it works not only for water, but any liquid and gas. So we can say that this principle works for any fluid. So the statement becomes, when a body is immersed fully or partially in a fluid, it experiences an upward force that is equal to the weight of the fluid displaced by it. So let's place Archimedes' principle on our concept board. We can summarize his principle as upward force is equal to the weight of the liquid displaced. We also saw in this video that the loss in weight of the body is equal to the real weight minus the apparent weight. And this loss in weight was used to measure upward force, since upward force and loss in weight are equal. Remember, I had promised a mnemonic at the beginning of this video to help you remember Archimedes' principle. So rather than upward force, you can remember it as upward force. Now let's split the word. So we have up equal to walled. So that is, upward force is equal to the weight of the liquid displaced. I hope this mnemonic helps you remember the principle. Now, how is the upward force related to the volume of the liquid displaced? We've learnt that the upward force is equal to the weight of the liquid displaced. And we know that weight is mass of the liquid into g, where g is the acceleration due to gravity. Now, what is the formula of mass? It's volume into density. So we get that the upward force is V into D into G. But I like to write it as VL dLg because it helps me remember that it's the volume and density of the liquid displaced and not the volume and density of the body. So let's go ahead and add this formula and the mnemonic that we learnt to our board. Here's a summary of what we've learnt in this video so far. I highly recommend you to pause here and take down notes. Now that we are done with Archimedes' principle, are you ready to move on to our top 3 questions on this topic? Here are the top 3 questions. I encourage you to pause here and try to solve them. I'll be posting a video on the solutions soon. You can find a link to the solutions video in the description below or search for it on my channel page. So I hope Archimedes' principle is as clear as water to you. So next time when you're going swimming, I want you to remember that it is the upward force of the water that is helping you float and swim. And also do remember to like, comment, and share this video and subscribe to my channel.
What's up everybody, safety is #1 priority, and for this experiment we're gonna need 3 glasses of water. I have 1 regular water, a second one with a lot of salt, we're gonna need salt, and the third glass, just half full glass of water, and you want some extra water in a bottle. And then we're gonna need 3 eggs and a spoon. Let's check out what we're gonna do. This is gonna be water density experiment. So we got regular water right here, just tap water. We're gonna drop an egg and we'll see what happens. You see, it's sunk. Like, you know, any normal egg would do, it probably will sink in the water. But this is like really salty water. I put a lot of salt, and then let's see, we're gonna drop an egg carefully, and it floats in a salty water because it's density, right? And we got the third glass of water right here. We're gonna put a lot of salt in there. You see how much salt I put? Mix it up. Make sure you mix it good. Let's put some more salt in there. We're gonna put this egg in there and let's see if it floats. As you can see, that egg is floating, right? Alright, and now we're gonna put regular water on top of the egg, like carefully, you know what I mean? See what happens. The egg actually stays in the middle. Why is that? Isn't that funny? Alright, check it out. The non-salty water, the egg sinks. Salty water, the egg floats. And why is this egg floating in the middle? And tell me, how does it work scientifically? And all the best explanation, thumbs up, awesome explanation, keep it up, and check out my next experiments.